That right there represents our change in temperature. But the thing is, we just need to change those degrees Celsius into Kelvin. And how do we do that? Remember, to go from degrees Celsius to Kelvin, you just add 273.15 to it. When we do that, we get 276.288 Kelvin. Now what we have to do is we have to isolate Q. We have to find joules. Now the closest place we're going to find joules are right here in kilojoules. So we need to find a way of isolating those kilojoules there. Now the only way I can isolate those kilojoules is if I find a way to cancel out these moles that we have. And the way I'm going to cancel out those moles is if I convert these grams that I gave to you into moles and multiply it times this whole thing. So what we're going to do here is we're going to start out with 2.319 grams. Now we can change this into moles because I gave you the molecular weight, the molar mass of the object. So we're going to say for every 1 mole of this substance, it's 192.75 grams. Grams cancel out, and we've just isolated our moles. I'm going to take myself out of the image so that we have more room to work with, guys. All right, so we have moles now. Now I can just multiply it times the heat of combustion. So this would be negative 4621.0 kilojoules on top, 1 mole on the bottom. Moles cancel out, and now I have kilojoules isolated. But remember, I don't want kilojoules, I want joules. So one more step. Kilojoules go on the bottom, joules on the top. Kilo is a metric prefix, so for every 1 kilo, it's 10 to the 3. When we work all of that out, that gives me negative 55,600 joules. So that's my Q. So I'm going to plug it up here. So divide that by the temperature we just isolated, and you'll get negative 201 joules over Kelvin. Now, this question seemed like a lot of information, and it is. But the thing is, just focus on what they're asking us to find. They wanted us to find heat capacity. Heat capacity is just simply Q divided by the change in temperature. We knew change in temperature immediately, so we just converted that to Kelvin. And then you had to work on isolating the one variable you needed. You needed kilojoules. You needed to isolate kilojoules. We isolated that by changing the grams I gave you into moles and then multiplying times the heat of combustion. Now, when they say heat of combustion, remember heat means Q. But more importantly, here it means delta H. They could have said the enthalpy of combustion also. That'd be the same exact thing, okay? So just remember, heat and enthalpy, the same thing.